ladies and gentlemen, my name is Dr. John Belkowitz, Director of Research and Development, Intelligent Concrete, where we make concrete do the impossible. A buddy of mine called me up the other day, ready mix provider. We were having a short discussion on a quick patch. If I could design any type of quick patch in the world, what would it be? So he set up the parameters for me, and I had it was a good think. It was a couple glasses of wine. And the quick patches are an interesting type of concrete. More often than not, they're intended to be semi-permanent. They end up becoming permanent, especially for some more remote areas. But let's get into what we were defining as a quick patch. So first of all, it was a concrete. It wasn't a grout. We're talking about size of 5 foot by 5 foot, maybe 18 inches thick. Definitely a highway that's seeing vehicular traffic, multiple axle or more than 2 axle, as well as high volume at high speeds. So this would be something that you would do a complete slab removal, a 5x5 removal, put a subgrade in, put a patch in, and then have to have the traffic open in about half hour. Now, the problem with that scenario is there's a certain minimum strength that you need to have traffic drive over it and open in that short amount of time. There are certain things that you have to do with the concrete. So the time frame was 30 minutes, which is pretty awesome. And the strength is somewhere around 2,500 to 3,000 PSI at a minimum. So that's what we're going to play with is, 2,500 PSI, 30 minutes set time. You figure that the concrete's going to be anywhere from half an hour to 60 minutes old when it gets to the job site for most locations. So let's just say 45 minutes to split the difference, and then we can play with that number from there. So by the time the concrete is in the hole, it's somewhere around an hour old, and then 30 minutes in there, so a total of 90 minutes. From when water touches cement, it needs to be 2,500 to 3,000 pounds per square inch, and that's your concrete compressive strength. So this is where I would start out. First of all, when it gets to the job site, I want it to be fluid. I don't want there to have to be time waste on consolidation and concrete coming down the chute. My primary material that's going to give me my strength in a rapid time is my binder, and the material in the binder that is more likely to set up faster when we look at Portland cement versus a supplementary cementitious material, it's the hydraulic material that's going to get us those faster strengths. So I would start off the bat with the type 1, 2 and or type 3 if there's one available in the local market. If not, a type 1, 2 is great. A type 2, 5, you're starting to dance a little bit dangerously because you're already dealing with some stabilization of those hydration kinetics with the type 2, 5. But a type 1, 2, a type 1 we can make happen. So let's say we've got a type 1, 2 because that's a worst case scenario. With a type 3, just pull back on the accelerator, maybe add a little bit more of the hydration stabilizer. But those are the two main materials that we're going to use. We're going to have a granular skeleton that is balanced with the binder matrix. Assuming that we have a good combination of a river rock, a 5767 with a concrete sand, you should have a porosity index of your granular skeleton somewhere in the 30s. Low 30s, high 20s, 29, 32. And with that, we're looking at somewhere between 800 and 900 pounds total cementitious. And I say total cementitious because I don't know your local areas. Here we have a really good sea ash, but because we're looking for 90 minutes total set time, I don't even want to mess with that. I'm going to stick with my type 1, 2. We've got some really nice setting type 1, 2s out here. And I would use 4 things. First of all, here in Colorado, we have to use air entrainment, so I'm not considering that as part. I'd actually use 5 things. 6 things if I had my choice of anything. But in your local ready mix plant, the 4 or 5 things. One is high range water reducer. I want that mix creamy and dreamy, somewhere around a 20 to 24 inch spread, coming down the chute into the form, consolidating well, but having a good consistency that a little vibration won't kill it, but not necessary if you get it there soon enough. I want there to be rock still floating up at the surface. So a high range water reducer to me is a must. Lower water cementitious ratio, I want no lower than a 0.35. That's my magic number over the years that I've been using for these higher early strength mixes. I'm also going to use a combination of an accelerator. There's some good ones out there. Calcium nitrites are great. They're expensive. Sodium thiocyanates, calcium nitrates. The sodium versions, stay away from calcium chlorides, although those will skyrocket in flight. Afternoon Delight, get you those strengths real quick. The chlorides can contribute to corrosion of the steel rebar. So that being said, good non-chloride accelerator, calcium nitrite, nitrate combination, and then a nice hydration stabilizer, sugar-based, ether-based. There's so many great chemicals out there, and I use them as a lever system. We need some bit of stabilization of hydration to get our slump retention in that 90-minute window. That being said, we want to be pulling something back with that hydration stabilization, and that's the dissolution and the accelerated hydration kinetics that you're going to get from the salts, those calciums or those sodiums. So you're holding that back with your hydration stabilizer, and finally, when acceleration has overcome what that hydration stabilizer can do, it's almost like letting go of that rubber band, all that energy, and it takes off like a bat out of hell. But that being said, a lot of heat is generated, and I believe there's a Kevin Folliard paper or Mike Thomas paper that goes over if you have more than a 40 or 30 degree temperature swing, you can get thermal cracking. So what we want to do is put some type of mechanism in there to mitigate that volume shrinkage, or mitigate not the volume shrinkage, because you're always going to have that, or compensate for the residual stresses that are created during that volume shrinkage. And that can either be fibers on a macro scale, on a micro scale, or even a nano scale, as well as shrinkage reducing agents, which can also be used as a hydration stabilizer or part of that hydration stabilizer package. So ultimately, my entire scope of this is to see that 45-minute drive time, that great concrete coming down the chute, maybe at the plant, it's at a 26, 28-inch spread. It's got that 45-minute drive time. You get onto the job site, they spin it up quickly, it breaks it up from gelling just a little bit more. So maybe now we've got a 24 to 26 at 45 minutes, and then maybe a little bit more time, we're an hour old, and it's a 20 to 24 inch spread coming down the chute, nice, creamy, and dreamy. And I mean, it's falling right between the mesh, the dowels, a little bit of consolidation. They're using a bar to get the aggregate down and just following the truck as it goes, and really just placing those 5 foot by 5 foot sections real quick. I mean, if we're talking about a 5 foot by 5 foot section, that's what is that, 25 square feet times another 1.5 foot for your 18-inch thickness. So I mean, we're talking about what? Somewhere a little bit under 3 cubic feet, a little bit over 2 feet, or 2 cubic yards. So with that, I mean, we could, easily get a 5 cubic or a 10 cubic truck out there and make that happen real quickly, and get that 2,500 PSI in 30 minutes, broom finished and opened up to traffic. And that's my favorite way of doing it. Depending on your local materials and what you have in the back of your ready-mix truck, there are different materials that you can play with, and some newer ones like colloidal silica, carbon nanotubes, alternative supplementary cementitious materials, to make that concrete more of a permanent material. But more often than not, those quick patches are designed to be semi-permanent. So hopefully you got something out of that. If you have any questions about that concept, I think we might be doing a day of mixing where we're designing one of those. We'll get back to you on that, but one of my favorite concrete mix designs out there. Hope you had as much fun as I did. Go concrete, beat asphalt.